Hello there. In this video, I'll be showing you how to make use of the project DownSampleMe. It's a custom processor implemented in Verilog Hardware Description Language for image downsampling. So let's get started. First, you need to make a clean clone of this repository. You can, or either you can simply download a zip folder of this repository. I have already made a clone of the DownSampleMe project. Here it is. And then you need to open Xilinx Vivado software. In this project, we have used the version 2018.2, but the project should be working in other versions as well. And once the Vivado software is open, click the Open Project wizard and locate the where you cloned the DownSampleMe project repository. Here it is. And then there is a subfolder name as processor. Double click to open that. Here we have the processor.xpr, the Xilinx project folder, project file. Select it and hit OK. Just give it some time. Okay. Once it is open, close the unnecessary tabs and expand the processor DUT processor tree. Here we have all of the modules that we have implemented in Verilog HDL. First, I will show you how to run the simulation with the default settings, the default image, with the default image. And in our project, we have hard-coded the image into the ram.v Verilog file. Here you can see it. Image data, 8-bit single channel image. To run the simulation, in the flow navigator bar, just select simulation and click run simulation, and then run behavioral simulation. This will take about, let's say, 5 to 4 minutes, and let's wait. You can make it run in the background and keep using Xilinx Vivado software by hitting the background button. So I'm going to press it. Seems like it's taking a bit longer as I'm running my screen recorder in the background. But this won't be a problem for you. Yeah, let's wait. Here we go. Once it's you, once it's waveform, a window is popped up, you can just maximize it, and you can observe that our program is running smoothly. Okay, seems like it's coming to the last stage. Yeah, the simulation finished successfully like that. Now you can see the complete signal is high. This indicates that the simulation is successfully completed. And now you can see the results. For that, go to the downsample.me project directory. Now you can see there's a file named as output.txt has been created. You see the time, observe the time. To visualize this image, we have a Python script to run that. You need to go to our repository on GitHub and go to the resources section of the README file. Simply scroll down. Here we have the resources. And in that, select Google Colab Notebook and open it. This will open a Google Colab Notebook. To run any script in this notebook, you first have to connect the notebook to a runtime. For that, just hit the connect button here. And then press the files icon. Still connecting. Okay. Okay. Now it's connected, and now you can run any Python script in this notebook. Now we are going to visualize the output generated by the Vivado simulation. For that, you need to upload that output.txt file to this runtime. And you can do this by pressing this icon upload to session storage. And go to the downsample.me project directory. I select output.txt and hit open. And it will be uploading the output of our Vivado simulation. And then you have to run this cell by pressing Ctrl plus Enter. Here we go. This is our output. And it gives this output as I have changed the image, the original dog picture. And if you need to change the input picture to the Vivado simulation, you can simply do that by following the method now I'm going to explain. For that, you need to upload new image, and you can find new sample images in our downsample.me image directory. Go inside image generation folder, 256 into 256. Here I have included some test images for you to play around. And now I'm going to choose the picture of Lena and click open it. Here it has been uploaded to the our notebook. And in order to include that in our Vivado simulation, we have to first convert our image to a format that is compatible with Verilog Hardware Description Language. For that, just rename the file name to a name of the image that you just uploaded and run this cell by pressing Ctrl and Enter. Okay, I'm getting up. Here it is. Then run the next immediate cell, and this will create a text file that includes our image, which is in a format that is compatible with Verilog HDL. Refresh the files in our notebook. Here is the output text file. Double click to open it. Now you should see something similar to what is displayed here. And you need to select all and copy that. I'm going to hit Ctrl plus A and Ctrl plus C to select all and copy. Now in the Vivado simulator, you can preset the simulation by pressing restart button. And from the flow navigator, you can close the simulation. Now we are going to change our input picture. So we don't need the previous simulation. Okay. In our project tree, you can see a Verilog file named as ram.v. This is where we have included our default image. You can double click to open that. Here you can see the image that we have included. Now we are going to replace that. Move your cursor to the in front of this RAM 20 line 86 and hit Control Shift and End button to select everything. And while pressing the Shift key and pressing the up arrow, you can localize the part that we required and press delete to delete that. And then we are going to copy, then we are going to paste our new image by hitting Ctrl plus V. Here we go. Now we have inserted the new image and hit Ctrl plus S to save. And you can run the simulation as previously by hitting run simulation. And this will take, as previously, few minutes. So I'm going to cancel the simulation and end the video here. Once the simulation is complete, you will see an updated output.txt file has been created in this DownSampleMe directory, and you can visualize it as I demonstrated earlier. Yeah, that's all about it. Thank you.